Okay, so now we're working on the 6-6 phase shift and sinusoidal curve fitting notes. The main difference between this lesson and the previous lesson is this part, which is minus phi. It's pronounced phi. So remember, like if you're in college, sometimes there are fraternities and sororities that use those letters, the Greek letters. Like I was in Phi Theta Kappa, so our shirt looked like this, Phi Theta Kappa, which was a National Honor Society. So there's different ones. Anyway, this is Phi Theta Kappa. Okay, so we're continuing our discussion of graphing trig functions. By the way, I updated my notes a little bit to include a hint from last section so that everybody can see it. I know when I was helping people individually, we ran across this, and I think this is a good way to remember how to do these functions and problems. You're going to graph, find your domains, asymptotes, and ranges. So for tangent of pi 13ths x, you would have your w as, you should change this to pi 13ths. I just made a typo right there. Change that to pi over 13. And so then your period would be, pi, because it's the normal period for tangent, divide by pi 13ths. Again, small typo, sorry about that. So then this would be 13. So then you want to look for graphs that go to 26 because it shows two periods. Then look for what happens at that point. If it's an asymptote, then by the concept of the middle, it will also be at 13. Cross out the pi. I made one small mistake here, which is like leading to a bunch of tiny mistakes. And if those are numbers for the x value, then use the concept of the middle again to get 13 over 2. You can also change your table settings for the independent to ask and see if the calculator shows undefined, UNDEF. It also sometimes shows a number with e to a positive number, like 5e to the 13, which you should interpret as infinity or negative infinity, which would be like undefined. Okay, so before I get to the next part, let me show you what I'm talking about. So let me just look at a worksheet. I think the easiest way to explain this is on a worksheet. On 6.5, the one I'm thinking about is number 6 in this time that I printed it. We have tangent of pi 13ths. So your W is pi 13ths. So your period would be pi over pi 13ths, which gives you 13. And so look for 26. So this one says 2 pi, so that's not it. This says 2 pi, it's not it. And tangent goes forward, not backwards. And so it'd be the C graph. This one would have looked a little bit like cotangent, but not exactly. So that would have been the C. And then what we're looking for is here it shows 26 has a number. So what that would mean is when we do our middle, 13 would also have a number, which in this case would be 0. Then you go from 0 to 13, and then take half, would be 13 halves, which is 6.5. And so you're going to want the 13 halves choice. And it does say odd integers, so it'd be like a 1, 3, 5, whatever. But that's how you choose the correct domain. These are the values where it's not defined. And then the range would be all real numbers for that one. Okay, so that's just a little side example. Any questions about that?
Yeah, I forgot the number.
That was number 6 on the worksheet. On 6.5, the 6.5 worksheet, not the 6.6 worksheet. Yeah, so I'm kind of doing a little recap because y'all have a classwork tomorrow. Okay, so I want to make sure everybody knew how to do this. Also, one quick thing, the part about the calculator, if you go to tangent pi 13ths x, there's your graph, and we would need to change it from negative 26 to 26. And that's where you can really tell it matches this one, because it's a partial here, and it's a partial on this side, and 3 in the middle. Okay, so that's how you can tell your graph. And again, if you go to Control T for your table, what we want is our independent. So go to Edit Table Settings. We want our independent to be ask. Okay, and then when we do that, we could put in 13 halves, and in this case it's undefined, which means that's, you know, your asymptote. If you did 1/13 or 3/13, because it's saying odd, then you get numbers, and so it's not that one. And on this one, it says k pi, so if you put pi, you get a number. If you put 2 pi, it's a number. So the main thing is I'm trying to show y'all that you can use your calculator to help you figure out this part. Okay? Now again, sometimes instead of saying the word undefined when it should, as I said in the notes, it could sometimes say 5 or some other number e to a positive number. And so then you're going to have to interpret that to be undefined. Okay? So I know I've seen that before on some examples as well, but undefined doesn't always show up, but if you see e to a positive number, then act like it's undefined. Okay, so that's basically my recap of 6.5 because y'all have a classwork tomorrow. The next part is we complete the chapter of graphing trig functions by including horizontal shifts with division by the number in front of x, and those are called phase shifts, and use your symbol. It's a circle with a vertical line, which is pronounced phi. Applications include alternating current, like AC circuits, hurricanes, monthly temperature, tides, and hours of daylight. On this one, just as another really quick note, no graph paper is needed. You're going to write your windows and other info. Okay, so for your notes, for number 1, it's talking about the distance from the middle line, and it's telling you it's the absolute value of A. That's the amplitude. Amplitude. Okay, and then period is T, and that's the normal period divided by W. sine, cosecant, CSC, and cosine and secant have period 2 pi. And so you'd have the period is 2 pi divided by W. So sine and cosecant go together, and cosine and secant go together. Okay? And then for this one, tan and cotan would be pi over W. Okay, so that part was kind of a review. Now for number 3, this is the phase shift. The phase shift basically means going left or right. If W is 1, then there's no number in front of x, and so the phase shift is simply moving left or right by however much it was. So for example, if you have sine of x minus pi halves, that would mean right pi halves. And you don't have to do pi halves divided by 1. Also remember, like we're about to say, minus means right, which is when phi is greater than 0, and plus means left, which is when it's less than 0. Okay, so here's your steps for figuring out all your points that you're going to use and for your graphs. It works with either sine or cosine. Again, we have A sine Wx. We sometimes call that omega. The W is omega. And then minus phi plus B. In some textbooks, they use A, B, C, and D. But your first step is determine the amplitude and the period and the phase shift. Amplitude, period, and the phase shift, which would be phi divided by W. The next is determine the starting point of one cycle of the graph, whether it starts at the origin or at pi halves or whatever it may be. Sometimes it may start at 2 pi thirds. Then you need to determine the ending point of that cycle. So basically taking that same number and then adding 2 pi over W. And then divide that into 4 subintervals. And then use your endpoints to find your 5 key points on the graph. And then from there, we plot the 5 points and connect them with the sinusoidal graph, meaning a sine graph, to obtain the one cycle of the graph. And then you want to extend that in different directions to make it complete. Now, the next part is step 5. If B, which is the vertical shift, is not equal to 0, then apply a vertical translation. And then, for some reason, this changed back to A. It's supposed to be F, like it is on mine. So use the above steps if graphing each step separate, because they sometimes want you to do several graphs for one problem. Now, we use our calculator, so we pretty much just do everything at once. And we start with the middle line and then go from there, like you'll see in the notes when we're doing problems. If you only do it once, identify the middle line first, and then the y-intercept, and then the key points and the possible asymptotes. Okay, so these are going to be your problems. We are doing number 29 also, and let's write our header. All right, so 6-6, page 428, numbers 1 to 2, 4 to 18 even, and 28 and 29. Okay, so for number 1, it says for the graph of y equal a sine wx minus phi, phi over w is the phase shift. That's the blank. Remember, on this type problem, I'd want you to use the whole thing. But if you were just doing this on Math Excel, it'd be phase shift, and there's no choices and no view and example, because it's just a definition. For the graph of y equal a sine parentheses wx minus phi, phi over w would be the phase shift. Notice it's not negative phi over w. You're going to have a sign change. Okay. Number 2, a true false. Only 2 data points are required. Only 2 data points are required for a sine function. Of best fit. This would be false. We said we wanted 5 points. And also note this part about when you're doing sine regression, with horizontal shifts is different. What I mean by that is you may have something that is like this, which looks like a minus sine graph, but it could really be a cosine graph, which is moved right or left. So this lesson is a little bit harder as far as doing your sine regression, your sinusoidal regression. Bless you. So again, this we called a negative sine graph because it's going through the origin and it's going down first. But it could simply just be a cosine graph that's moved one way or another, to the right or left. Okay, number 4, on these type problems, what you want is you want to find your amplitude, your period, and the phase shift. And also write the window. Which would have things like x min, comma x max, and y min, y max. So that's what you're going to see throughout these. I'm not having y'all graph it on graph paper because we've already done that for 2 lessons. And when you're doing horizontal shifts, it's even more complicated to graph by paper. So we're just going to graph on Math Excel and put what our window is. And graph those on the calculator. Okay, so for this first one, we have y equal 3 sine 3x minus pi. So basically write everything I write with these. The first thing is our amplitude's 3 and our w is 3 because it's the number in front of x. Now, based on the w, which is also sometimes called the frequency, then you get your period is the normal period divided by w. So the normal period, since it's sine, would be 2 pi. So we're going to have 2 pi thirds. Now, since we're showing 2 periods worth, what that means is for x, we're going to go from negative 2 pi thirds to positive 2 pi thirds. So that's how all of that is related, because they still want you to show 2 periods worth. And so you take your period, and so one period would go from 0 to 2 pi thirds. The other would go from negative 2 pi thirds to 0. So together this is showing 2 periods. Then for the phase shift, the phase shift would be pi over 3. And since it's positive, that means it's right. It's going to the right by pi thirds. There's no number out to the side, so there's no vertical shift. And so then for our y part, we just use our amplitude with negative 3 to 3. Okay, so that's all you have to write for it. I know it's kind of a lot, but we're going to graph this on the calculator. So we go 3 sine 3x minus pi, enter. So it's very wavy the way it is. And I need my axis to change. So you can either double click the negative 10 or you can change your window settings. Looks like it's going to be easier for me to just change my window settings like through 4 and then 1. And I want this to be negative 2 pi over 3, positive 2 pi over 3. So that gets us to the right horizontal part. I needed to do the vertical part also, which would be make this negative 3 to 3. Okay, so then this is what they call a good graphing window of it. There's no wasted space. It's showing 2 periods worth, and it's going from the bottom all the way to the top. Now, the disadvantage of doing this is you can't really get your y maximum by doing, left bound and right bound, because you just need to go by the number 3. I think that'll be right. If we go to maximum for this one, the left bound and right bound, oh, it is going to show me. So it's 3. I thought since I was so close to the top it wouldn't work, but it did. Okay, any questions about that one? Okay, number 6, this one we have y equal cosine, sorry, it's 3 cosine, parentheses, 2x plus pi. 3 cosine 2x plus pi. So our amplitude's 3, our w is 2, just from the numbers. And so our period would be the normal period for cosine, which is 2 pi, divide by w, and so we just get pi. Which means our x part is going to go from negative pi to pi. Yeah, x is always related to your period. Again, there's no vertical shift on this one, so then we just need to do our phase shift. So you've got a positive pi or a plus pi. We've got to change it to minus.
Wait, why?
We always change the sign, just like we say, this one went to the right, not to the left. It's the opposite of what you think. The formula works like with a minus sign built into it right here, and so you got to change your sign. So the phase shift would then be minus pi halves, which means it's going to be left pi halves. And because there's no vertical shift or vertical translation, we just use the 3 and go from -3 to 3. Okay, so now let's graph that one and see how that works. Three cosine 2x plus pi. Okay, let's go to our window settings. We go from -pi to pi. And we want to go from -3 to 3. Okay, so that's showing you 2 complete periods worth. So that's the window you would use. Bless you.
Thank you.
Okay, so that's number 6. Number 8. This time we have y equal -2 cosine 2x minus pi halves. So remember that little minus sign right there in front of everything means it reflects the x-axis. By the way, when you're graphing these on MathXL, there is a little box for phase shift, and so that's where you end up putting that. This one, you have your amplitude would be the absolute value of -2, which is +2. Your W would be 2. Since your W is 2 and it's cosine, you have period is 2 pi over 2, which is pi. So just like on that last one, we go from -pi to pi. That's our x's, from -pi to pi. So this is your x min, this is your x max. Now we need our phase shift. Do you put what? Yeah, that would be fine. Your phase shift would be positive pi halves over 2, and think of it as 2 over 1. So then you multiply your outsides and your insides to get pi fourths. So then this would be right pi fourths. You always do this number over whatever's in front of x. Yeah, and sometimes there's nothing there, so just think of it as 1. So that's going to be your phase shift. We also need our y minimum and maximum, and it's going to go from -2 to 2. Okay, so let's graph that. We're going to have -2 cosine 2x minus pi halves. And we need to change our y from -2 to 2. Okay, so there's your window for it. Again, that's 2 periods worth. Any questions? Okay. So again, like I was saying earlier, this looks like a negative cosine graph. I'm sorry, it looks like a negative sine graph, but it actually was a negative cosine graph, which was moved to the right pi force. It's just one extra step with the horizontal part. Yeah, you can't assume this is a negative sine graph if you're doing a horizontal shift. On the Math Excel for 6.5, you wouldn't have this part, and so you would like assume this is a negative sine graph instead of a negative cosine graph. Just graphing it like we're doing here. Yeah. Okay. So next we have number 10. This one is y equal positive 2 cosine 2 pi x plus 4 and then plus 4 again. Okay, so we've got lots of numbers on this one. We've got our amplitude, which is 2. We've got our w, which is 2 pi. So because we know our w is 2 pi, we're going to say our period is our normal period divided by w, so that'd be 2 pi divided by 2 pi, which is 1. So then x would be from negative 1 to 1. So that's your horizontal parts. Now as far as the phase, it's a plus, so we're going to change the sign to make it minus, and we do 4 over 2 pi. So you have to simplify that to be negative 2 over pi, which means left. The other part on this one is you have a vertical shift. Correct. Vertical shift of 4. So the way you would start it is at 4, you're going to go down 2, and you're going to go up 2. So think of that as 4 minus 2, which is 2, 4 plus 2, which is 6. And then we can graph it to see if we're right. Okay, so we have 2 cosine 2 pi x plus 4 and then plus 4 again. Okay, so again, very wavy because we had such a high frequency, because the W is the frequency. We need to change our settings to be from negative 1 to 1 instead of negative 10 to 10. And then we need our Y minimum to be 2 and our Y maximum to be 6. And so now it just looks like a normal graph. You know, this is 1 period worth and this is the other. Any questions? Okay, we'll do one more for today, number 12. And this one is y equal 2 cosine 2 pi x, so pretty much like the previous one, but this time we have a minus 4 and a minus 1. So again, our vertical shift is minus 1, which means your middle line is y equal negative 1. Okay, these other things would be the same. You'd have A is 2, W is 2 pi, period is 1. So all of those were the same as number 10. And then for your phase, it'd be positive 4 over 2 pi, so that's 2 over pi. And since it's positive, that means it's right. Right 2 over pi. So our x's would look like negative 1 to 1. Our y's would start at negative 1, because that's our middle line, and then use the 2, so we go down 2, and again start at the middle and go up 2. So this means you go from negative 3 to 1. Okay, so let's just change this to be minus 4. And change this one to be negative 1. Okay, so it's not showing up on our current windows, so we just have to go to here, keep it negative 1 to 1, but then this needs to go from negative 3 to positive 1. And there's your window. Okay, any questions about that? I think it's too close to the bell now. We've got 2 minutes. Okay, we'll continue this tomorrow. We've just got a few problems left, but a couple of them are word problems.